Hello everyone, welcome to Payment Tech Media. In this video, you are going to learn how to convert a binary number to hexadecimal number. So as we talked about earlier, binary is a base 2 system. We have only 0 and 1. 0 means off, 1 means on. And hexadecimal is base 16 system. Hexa means 6, like hexagon, and looking at word decimal, deci corresponds to 10, 1/10, decade, 10 years. Therefore, 6 plus 10 is 16. So hexadecimal is base 16 system. In hexadecimal, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then A, B, C, D, E, F, which A in hexadecimal number system corresponds to 10 in decimal system, B corresponds to 11, C 12, D 13, E 14, F 15. To keep the single digit, we have A, B, C, D, E, F instead of 10, 11, 12, 13. So 0 to F, that's a total of 16 different numbers. Therefore, hexadecimal is base 16 system. To understand this better, for every hexadecimal number, we have 4 bits. So let's put these place values. For hexadecimal, we have 4 bits per hex. And as we already know, for the decimal values, 1, 2, 4, 8. Where are they coming from? 2 to the power of bit position. 2 to the power of bit position. So for every hex, we have 4 bits. We are talking about binary digits. So base is 2. 2 to the power of bit position gives us a decimal value. Now let's look at the range. So if this section here is the hex, and here is the binary, and here is for the decimal. So if we have 0 for the hex, binary would be 0, 0, 0, 0, and decimal would be 0. And if we have F, which corresponds to 15, right? So I'm going to write down 15 here. And to get 15, we turn on all the 4 bits. So here, 1 being turned on, 2 turned on, 4 turned on, and 8 turned on. Therefore, 8 plus 4, that's 12, plus 2, that's 14, plus 1, that's 15. So it gives us 15 in decimal value. Therefore, for every hexadecimal, we have 4 bits, depending on what is the value of hexadecimal. For example, let's say if we have 5 hexadecimal, so 8 is off, 4 is on, 2 is off, and 1 is on. 0, 1, 0, 1. That's the binary for this hexadecimal 5. 4 plus 1 is 5. And here we can see 4 is only on, and 1 is on. And the decimal value is 5 as well. So I just wanted to show you guys this first and inform you guys that for every hexadecimal, we have 4 bits. Depending on what is the value of the hex, some of the bits being turned on and some of them being turned off. 0, all the bits turned off. 5, these 4 bits, only 2 of them turned on. And F, all of them turned on. So again, if we have only 3 bits, it's not enough to cover all the hexadecimal number. And if it's more than 4 bits, we will have more numbers that we don't have in hexadecimal number system. Alright, now let's take a look at one binary number and we want to convert it to hexadecimal. 110101100101, for example. So what we need to do first, we have to count right to left, and every 4 we have to separate. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Why every 4? Because for every hexadecimal number, we have 4 bits. So I'm going to write down these binary numbers here in groups. So let's say if this is the first group here, the second group here, and the third group here. Next, we need to write the decimal value for these binary numbers. 1, 2, 4, 8. 1, 2, 4, 8. 1, 2, 4, 8. And where they're coming from? Base 2 to the power of bit position. This is bit position 0, 1, 2, 3, and base is 2 because of the binary number. We have 1 and 0. Okay, so here we can see 8, 4, and 1 turned on. This one 4 and 2 turned on. This one 4 and 1 turned on. In every group, we just need to add the numbers that it's being turned on. So in this group, 8 plus 4 is 12, plus 1, 13. Let's write 13. And of course, in hexadecimal, 13 is D, as we can see here. So I'm going to write down D. In this group, we can see only 4 and 2 turned on. So 4 plus 2, that's 6. And in this group, we have 4 and 1 turned on. So 4 plus 1, that's 5. Therefore, this binary number is equivalent to D65 in hexadecimal number system. So we can say this binary is equals D65 in hexadecimal number system. Or sometimes the hexadecimal numbers we might see 0x D65. This 0x is just a prefix telling us the following number is hexadecimal number. So this D65 is a hexadecimal number. Now let's see it in the calculator. So here we can see standard view, change it to the programmer view. And we want to make sure BIN for the binary is selected and putting this binary number into the calculator. 1 1 0 1 0 1 1 0 0 1 0 1. And as we can see here for the hex, D65. And here we can see D65. Okay, let's go over another example. Let's say 1 1 0 1 0 1 1. And we want to convert this binary into hexadecimal. So what we need to do first, counting right to left, every 4 separate. 1 2 3 4 separate. 1 2 3. Probably it was 0 here that they didn't show us. So 0 to the left doesn't count, right? So that's also groups of 4. And that is why we are counting from right to left. Because there could be 0 to the left and they didn't put the 0. And next we need to put the decimal values. This is 1, 2, 4, 8. 1, 2, 4, 8. So in this group we have only 4 and 2 turned on. And this group 8, 2 and 1 turned on. 1 means on, 0 means off. Now let's add them together. In this group 4 and 2 turned on, so that's 6. And in this group 8 plus 2, that's 10, plus 1, 11, which here we can see 11 is B in hexadecimal number system. So we need to write B here. So this binary is equivalent to 6B in hexadecimal number system. Let's take a look using calculator. So changing the view to the programmer and putting the binary. We want to make sure binary is selected first. So putting this binary number, 0 to the left doesn't count. So 1 1 0, 1 1 0, 1 0 1 1, 1 0 1 1. And as we can see, in the hexadecimal, 6B. So because BIN is selected, we have only 1 and 0. If I clear the calculator and select hexadecimal, we can see A, B, C, D, E, F also is available because in hexadecimal, numbers are 0 to 9 and then A, B, C, D, E, F. So right now hex is selected. If I put 6B, I can see the binary is the same as this binary number. So anytime when we see a binary number and we want to convert it to hexadecimal, The first thing we need to do, count right to left every 4 and separate. And then putting the decimal values 1, 2, 4, 8, 1, 2, 4, 8 for every group. And then the ones that are being turned on, we just need to add the numbers. And if the number is larger than 9, we need to write down the A, B, C, D, E, F. In this case, it was 11. 8 plus 2, 10 plus 1, it's 11. So we need to write 11 is B. We need to write B here. Therefore, this binary number is equivalent to 6B hexadecimal number. This was a quick overview of how to convert a binary number to hexadecimal number. Thank you so much for watching. If you have any question, please leave it in the comment section. If you like the video, please hit the thumbs up. And to see more videos like this, please subscribe to our channel. Thanks again and have a good day.